Part 2. You always want to write the reaction of interest because you want to know what's going on. This particular reaction is zinc ions, aqueous, plus hydroxide, ions, aqueous, goes to zinc hydroxide. In this particular case, it's a solid. And the solid is a white precipitate. It's a white precipitate. These are colorless. So when you see a test tube that is colorless, it basically tells you it's predominantly these chemicals. When you see a test tube that has a white cloudy tinge to it, or even a white precipitate, you can essentially say it's dominated by these chemicals. These chemicals will all be in the mixture. Don't get me wrong, okay? These chemicals will all be in there. Zinc ions, hydroxide ions, and zinc hydroxide. But again, the observation that you have tells you which chemicals is in the majority. If there's white precipitate, this is the majority. If it's colorless, these are the majority. But they're all in there. So this is what you guys are going to be doing. First, you're going to take a test tube. And then you're going to add to that test tube about 20 drops. 20 drops of zinc nitrate. Now, if you don't want to count 20 drops, just add 1 milliliter. 20 drops is about 1 milliliter. Okay? And you know how to add 1 milliliter because these things are calibrated. There's a mark right here. You draw it up to that mark, 1 milliliter, and then you just add all of those into this test tube. And that's zinc nitrate. The chemical that you're adding is zinc nitrate aqueous. Now the nitrate, if you guys remember from chapter 6 or stoichiometry, is going to be a spectator ion. It's not going to be involved in this equilibrium. You only want the zinc from this chemical. You want it to come out as zinc ions. Okay? So that's the first thing that you will do. And then in 2B, this is 2A, procedure 2A. Then 2B, according to the direction, you guys are going to add, sorry, I forgot. To the zinc nitrate solution, sorry, jumped the gun, you also add 1 drop of sodium hydroxide. And this is 6 molar sodium hydroxide, so it's very concentrated. The hydroxide here and the zinc here will form this equilibrium. So by the time you finish this first part, you now have this equilibrium. You have some zinc, you've got some hydroxide, and those two are forming zinc hydroxide. Don't be surprised if you see a little bit of white particulates in the test tube. Okay? Then in 2B, what you guys are going to be doing, the next step, is you're going to take that test tube and then you're going to be adding hydrochloric acid. And again, you can see that from this equilibrium, the hydrochloric acid is going to attack that. Okay? So you add 6 molar hydrochloric acid dropwise. Dropwise just means that you keep adding to this solution until you see a change. Okay? And hopefully, this stuff that you see initially will change when you start adding hydrochloric acid. And then you can put that, and you can put that on the waste because you're done with that procedure. Okay? The next step is to prepare a second solution. In fact, do 2 of these in the beginning. Okay? 2 of these in the beginning, where you take some zinc nitrate and you add 1 drop of sodium hydroxide. So you have 2 test tubes of this guys. One of them you add hydrochloric acid. The second one you add sodium hydroxide. So you take that test tube with a Burrell pipette, you add additional sodium hydroxide. Okay? Until you see, again, a change in here. What you can do now is in each of these experiments, I've sort of modified it. So you have to determine the thermicity. Is this endothermic or exothermic? What you want to do is, of course, put this in hot and cold water. And see what happens to those solutions in hot and cold water. Okay? If in hot water you get more white precipitate, that means that the reaction is endothermic. If in hot water you see the white precipitate disappears, that means that the reaction is exothermic. Because if it was exothermic, adding more energy, increasing the temperature, would drive the reaction in that direction. So you can see why you want to modify the experiment by putting these last test tubes, before you get rid of it in the waste container, you put it in hot and cold water. That way you know whether it's endothermic or exothermic. And that's because the post-lab questions will ask you, or some of the questions in the lab will ask you, what is the thermicity? Is this reaction endothermic or exothermic? And this is the way you can determine that. Do the experiment, look at the results, and then draw conclusions from that result. You're done with this part. Okay? This part's pretty straightforward. You just add zinc nitrate, add some acid, add some base, and then you're done.